In this video on formal geometry, we'll be talking about triangles, isosceles and equilateral triangles. So this is triangles too, meaning that in the previous video we studied about triangles, the sum of angles in a triangle and the exterior angles of a triangle being equal to the opposite interior angles of that triangle. So in formal geometry, we prove geometrical theorems. We don't just do experimental. We prove them using reasoning, like in a mathematical way. So in this video, we'll be proving that the base angles of an isosceles triangle are equal. That's what we're going to be proving here. And okay, so let's start with the proof. So we've been given a triangle here, and we can see that this side and this side are equal, shown by these two small lines drawn on the sides of the triangle. Okay, so let's start proving the normal way we do that. Okay, so we have given any triangle A, B, C, just like we have in this diagram. And then what we are to prove that these base angles, angle B is equal to angle C. So once again, these are the base angles of this isosceles triangle. Isosceles triangles are triangles that have two equal sides and one side is unequal. And then we know from geometry that the base angles, that's the side we call the base, is the unequal side, the side that is not equal like the other two sides. That's what we call the base. So the angles at the base are equal. And then the angle at the vertex, that is this other angle, is called the vertex angle or the vertical angle. It is the unequal angle. Okay, so we are to prove that these base angles, angle B and angle C, are equal to each other. Now, in this particular proof, we are going to have some constructions. So, construction, it is not in every proof that we have construction, but in this particular one, we have construction. So, our construction is, we are going to draw a bisector of angle A. Draw bisector of angle A to meet this line BC, at a point. So we'll call that point D. So we're going to draw a bisector of angle A. It doesn't look like, okay, but let's just believe that this is the bisector of angle A that's meeting line BC at a point which we call D. So we've done our construction that will help us to get this right, and then after that we are going to name this part, this angle, we're going to name this angle, let's say X, and then this other angle Y. Why did I call it X? Please, this Y. So this is bisector, so X is equal to Y. So we've done our construction. Now to the proof itself. Okay, so we are going to use congruency of angles of triangles to prove this. So we are going to say that line AB is equal to line AC, and it is already given because this is an isosceles triangle and these are the two equal sides. So the reason for making this statement is that it was given. Okay, so we are also going to see that this line AD is being shared by the two triangles. So we have that line AD is equal to line AD. And then they are same sides, as we can see, same sides. Okay, and from our construction, we could see that angle X is equal to angle Y because we constructed that. Angle X is equal to angle Y, and then the reason is that it's from construction. We said the bisector of angle A, construction. Now, having seen this, we have two sides that are equal and we have two angles that are equal. So, we are going to say, therefore, triangle ABD, because this has divided this into two triangles, triangle ABD is equal or even equivalent to triangle ACD. And our reason for making this statement is that it satisfies side, angle, side. Just like we can see in the diagram. You could see side, that's side, angle, side are equal. ABD and ACD. Okay, so we've proved that these two triangles are congruent. They are equivalent triangles. But remember that in every proof we do, the final line on the proof is that thing we went out to prove. Therefore, angle B is equal to angle C. Because since the two angles are equal, we can see that they are corresponding angles in the two triangles. So our reason is that they are corresponding angles in triangles ACD and ABD. So we've proved that. That's the end of the proof. Okay, so we are going to solve some examples that will further help us to understand this. But before we go, we said that in this video we are looking at isosceles and equilateral triangle, right? Good. So an equilateral triangle can also be seen as a special form of isosceles triangle. But in this case now, all the three sides are equal. So same proof can still be used. And in an equilateral triangle, all the sides are equal and all the angles are equal, and they are equal to 60 degrees each. Now, in this video, we talked about congruency. We have four reasons to, like 4 ways of looking at congruent triangles. We have all the three sides are equal to each other, side, 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 like we saw in this proof, side, angle, side. And then we also have angle, angle, side, or side, angle, side, angle. And then we also have right angle, equilateral, no, right angle, hypotenuse, and a side. So, and before we go into examples, there are other things we can notice from an isosceles triangle, that is in this proof. The other things we can notice is that the bisector of the vertical angle also bisects that base, that's the base of the triangle, that's this unequal side. The bisector of the vertical angle, that is the unequal angle, also bisects this line. Just don't mind my triangle that I drew. It's not really looking nice, but that's what we can get from what's it called again, isosceles triangles. And then another thing we can get is that the bisector of the vertical angle, this line, meets this one at right angles, meets the base at right angles. So this is angle 90, this is angle 90. Those are the things we can get from this proof. Now next we'll be solving examples.